Good afternoon, everyone. My name is Chinmay Tripathi. I'm Senior Director of Engineering at McGraw Hill. And today we'll be talking about how we survived and thrived during pandemic and helped millions of students learn remotely. But before that, a quick introduction on McGraw Hill. We are a learning science company. And our data scientists are constantly curating millions of data interactions, which is created by our students, authors, instructors, by interacting with our digital products. And they are trying to identify patterns, trends, and opportunities to improve learning outcome for individual learners, as well as also helping improve the experience of our teachers. On the technology scale, we have 80+ dev teams, 400+ applications and services, more than 150+ accounts in Amazon, and we're also expanding into other cloud vendors. More than 50+ Kubernetes and ECS clusters, and overall we have more than 4,000 EC2 instances running in the cloud. So 2020 started like any other year. But soon normalcy ended when the pandemic hit. We started to hear about colleges and schools were going to close down. By mid-March, it was certain that the colleges and college campuses and universities are going to close down. We formed a COVID-19 response team, and we started to coordinate outreach to the educational communities and offer our help and support so that they can navigate into this new world. Many of the teachers and instructors were asked to fully transition from in-person to online classes, and many of them had no idea, and they had never experienced teaching online classes. Here is the timeline. I wouldn't go into the details, but the slide will be available. This is 1 week in the March when we had millions of emails sent out to the instructors. Hundreds of webinars and training sessions were conducted while there was literally a chaos going on. More than 100,000 new students enrolled in our digital platform. We also offered free access to our ebooks and our digital platforms. We were already seeing an uptick in the traffic to our systems. And by opening up our digital platforms and making it free, only increased the traffic volume into our servers. And I have a couple of graphs here. If you can see, we have a cyclical business, and we know what to expect generally. And here is a 3 years worth of data. You can see that there is a huge spike after pandemic hit. There's another graph for another key transaction we have. So it was a great business decision to offer help and support and reach out to the instructors and colleges and things like that. But what if our systems were not built to handle this extra load? What if systems went down during the kids taking assignments while everybody is running remotely? So what happened? What did we do? And I was listening to the talk earlier today when somebody said the success in SRE is silent. And I think that's what happened. Pandemic was a non-event for us. We didn't do anything. I mean, we did ship features and try to create new courses for instructors and colleges, but we didn't go out and hire a bunch of SREs to support our systems and scale them. None of that happened. We were built to scale. We had prepared for future, not knowing that this will happen. But I think that is the story of this talk, the story of preparation for the future. Before we get into that, let me give a quick rundown on how we have evolved. We are primarily a cloud-first company. We have embraced cloud fully. So a quick introduction on how we have evolved from a handful of applications to a full scale we operate today. So chances are, if you are in cloud today, you are trying to utilize the resiliency and the agility which cloud provides. And that's how we started as well. Took a bunch of applications and started migrating them into the cloud. And then you see the initial success, and then you start to migrate more and more applications. And that's what we call share house. where you have multiple teams working on in an account, you have multiple projects going on, and this model works for a while until somebody makes a mistake and changes a security group or NACL rule, a routing table changes, or maybe change an AMI, and you find out that your application in production is broken. And then we move from that model to sort of split your environment from one account to dev and test and production. That helps a little bit to some degree. A lot of companies stay in that model for a few months, maybe a year, until they realize that business wants more agility. They want more releases. They want faster pace of innovation, which means you're not operating with 10, 20, 30 services. Maybe you're operating with hundreds of services. Now this cloud team or DevOps engineers or SREs, whatever you call them, you're not able to scale them. You can't just scale this cloud team linearly with the growth of services you want to deploy in cloud. And we had the exact same challenges. So we started writing a bunch of IAM policies. We will have the separation of duties. This team will only have access to these resources and things like that. However, that didn't work. And the reason for that was IAM policies are hard. You can try it, but eventually it will not scale. The solution for us was to create account for a two-pizza team and sort of go from 3 accounts to hundreds of accounts in matter of less than a year. Now we have solved the problem of agility and the freedom. Now developers can go and build their stuff without worrying about accidentally making a mistake and affect other services in other accounts. And that was sort of our evolution from few accounts to hundreds of accounts and networks, and then we also expanded into various different other cloud vendors. As I said, ours is a story of scaling. And when we talk about scaling, we primarily think of compute scaling or storage or networks. But I think the most important thing is to scale your people, processes and culture as well, before you get to the real technical bit. So people, I think the huge learning for us was to bring your cloud learnings to the whole company. Don't just go out and create cloud and create silos and segment things and split into camps. That just does not work in the long run. Training, invest in your employees' training. And we did that. We are a learning company, so we believe in constant and continual learning. So we have given our engineers, employees, access to free training materials and courses. However, we heard that some of the employees said that we just don't have time. We are so busy. So we thought about it, and we instituted a policy where everybody can spend 10% of their working hours learning. And that was very powerful. Rather than us expecting your employees to spend their weekends or after hours learning, they can use the company time. And that has helped us tremendously to scale our people from SRE, a handful of people, SREs, to hundreds of developers. Processes. Smart processes versus burdensome processes. For example, your change control. Rather than reviewing every single change, you want to review your automation policies. As long as you're applying the best practices of CI/CD, automation, and deployment strategies, your change advisory board can review those policies rather than going into individual change. And of course, governed by having preventative or detective guardrails. And I'll go into details in that later. Culture, a big one. Culture for us is how we get things done. And for us, that means empowering our teams. Developers are the kings today. So we have a terminology called shift left. You will hear a lot in McGraw Hill. And what it means for us is pushing things back to the developers, giving them the power so they can do things and have sort of ownership and accountability, and have some collaboration for decision-making processes. This just evolves in a homogeneous agile practices. And that brings me to some of the key learnings on the technical side of scaling. Obviously, there are many things to cover. I'll touch base upon few things which I feel has helped us tremendously in the last few years to be able to operate at the scale we do. And the first is governance first. Let me explain what government is. While we may agree or disagree on how big or small a government should be in our lives, But we'll all agree that we need some sort of government who can protect us from internal as well as external actors. Also, government needs to provide some shared services. In our lives, think about roads, infrastructure, transport, or schools, hospitals, things like that. But at the same time, maintaining freedom of people, and that is the key. I think we can adopt the same learnings into cloud governance as well. So identify your rules and regulations. What are the rules and regulations you want to live by? And this will vary from organization to organization. I'll give a few examples. What are the regions you want to operate in? Because not everybody is going to operate in every region. But restrict it to only the regions which you allow. What are the operating systems or AMIs you want to allow? What is your monitoring strategies? What is your container orchestration strategies? What's your data security strategies? Do you want to encrypt all your databases, S3 buckets, your servers, and disk? Once you have identified these rules and regulations, the next question to ask is, how are you going to scale it and enforce it across hundreds of teams and hundreds of services? So you need to have some sort of a consistent mechanism to be able to enforce these rules and regulations so that you are not necessarily manually managing these things, but it's fully taken care of by automation. The second aspect of governance is shared services. Now, shared services, for me, for us, has been the building blocks of these. When we go from few accounts to hundreds of accounts, you need to have certain infrastructure in place before the developers can start building their services. Think of networks. Think of identities. Think of encryption security policies. And the last is guardrails. Having real-time guardrails is absolutely imperative to be able to operate in cloud. If you do not want to allow port 22 from internet, you don't want to. You want to have it some sort of mechanism which removes such rules anywhere in your cloud and not just depend on the best practices. The next was everything as code. At McGraw Hill, we practice everything as code, not just infrastructure as code, because I think that is a very common knowledge these days, and I'm sure a lot of you use CloudFormation or Terraform. Expand this into other areas as well, like monitoring as code. You want to monitor everything in code itself. How about security as code? How about compliance as code? Right? Rather than auditing your environment and generating a report and then working with the team that, hey, why are you running this service internally? Do it in the code. And as soon as something anomaly happens, you send out an alert or maybe even prevent it from happening at the first place. Operations. Generally, the operations tasks are the last one to automate, things like patching your servers or some network changes. That needs to happen in code as well. And that is key for scalability. And the last is reusable code blocks. We use Terraform heavily to manage our infrastructure. And we have a working Terraform committee and group, which is essentially tasked to create shared Terraform modules. So if your company is using ECS clusters and everybody is launching services in the cluster, have some sort of a module which everybody can just use. And that scales very well for us. Security and networking, and that's a big one as well, especially when you operate, when you hit that hyper-growth trajectory in cloud. Security cannot be a blocker. Networking cannot be a blocker. It should not slow you down. So think forward and have a plan. I'll give an example. Many times people go into cloud and they just use the default VPC. When you deal with acquisitions and when you get new networks from other companies, you find out that it doesn't work very well. You cannot connect these default VPCs because they all use the same CIDR ranges. So just make sure that you don't use the default VPCs and you do not have overlapping CIDRs, because that will be a problem when you're trying to scale your networks later. Let me quickly touch base on DevSecOps. DevOps is, we all know it, developers check in the code, CI kicks in, you build your packages, you deploy the application. Inject some sort of security controls in there. So you have an opportunity there to have some sort of pre-commit hook to maybe not have your secrets and passwords leaked into your version control. You have an opportunity to code linting as well as static code analysis. And of course, when your artifacts are built, there's an opportunity to scan your artifacts and Docker images and things like that. But the biggest differentiator for us has been adoption of an AMI pipeline. There was a time when we were running 1,000 plus AMIs, and that just is wrong. Every organization has some rules. You have to monitor your application, so you need monitoring agents. You need log agents. You need security agents. And it is extremely hard if you have thousands of AMIs. Who is going to ensure that these AMIs have the right set of agents and they are getting updated? Of course, patching is a different issue altogether. So we instituted a policy and created a build and publish pipeline for all our favorite operating systems like CentOS or Red Hat or Windows, whatever have you, and create a consistent way to build these AMIs, scan them against your security vulnerabilities, and then publish it across hundreds of networks. Every month, in the first week itself, all these AMIs gets published across hundreds of networks for generic consumption. And of course, rotate these AMIs as often as you can. We have a policy of rotation every 30 days that keeps us fairly safe from security vulnerabilities. But my recommendation is also to have some sort of fallback patching mechanism. When things like Spectre and Meltdown happen and your CIO calls you that, hey, you have to patch your servers immediately, and you just don't know where to start. You have hundreds of networks. You have thousands of EC2 instances. How do you do that? You have to invest in that. AMI's rotation work, but we have realized that having the ability to patch at will helps tremendously. Moving on, and here is the architecture. We have a centralized AMI bakery where we build these AMIs. And after it has been scanned by security, making sure that there are no CVEs or critical CVEs in those AMIs, it gets published to all the accounts. And of course, have a mechanism to deprecate your AMIs, because as I said, thousands of AMIs, and I'm sure some of you might relate with this, they not only cost money, they're extremely difficult to manage and pose extreme security risk to your organization. Now, let's move to the network scaling. Each of these topics can have their own hour-long presentation, so I'll try to hit the high points. When we expanded from one network to hundreds of networks, and when the microservices architectures were used and teams were building services, you suddenly went from tens of services to hundreds of services across the organization, and they need to talk to each other. You don't want these services to be going over internet, because that is, first, not reliable. Internet speed is not consistent. And second is it exposes your APIs to public where it doesn't need to be. So you need to have a way to connect these networks internally. We were using, in Amazon at least, we were using something called peering. We'll peer these networks when we get the request from teams like, hey, we need to talk to another service, and that's in a different account. Can you peer these networks? And we will do that. And it works for a handful of accounts and networks. When you have 5, 10, you can create a mesh network, and that works. But when you go to hundreds of networks, it does not. You have to have some sort of a hub and spoke model. Here we have Transit Gateway in the center. It is connected to all the other networks. And any service in any of these networks need to talk. They have a route. They have a path. And none of these traffic traverses the internet. You have not only solved the performance issues, you have also improved your security posture for the organization. This was probably one of the largest projects we had to work on. And I would recommend if you haven't done it, you get ahead of this problem now before it is too late or before it becomes very difficult. Somebody once told me that this project was akin to building an airplane while it was in motion. And that was true. You do not want to disrupt any of your services and applications while you are making these network changes. So get ahead of this problem early on. That will help you. And of course, it reduces toil tremendously. Now you are no longer peering and no longer getting requests to peer networks. It just works. And of course, have it fully automated so that when you are provisioning new accounts, it gets connected to your Transit Gateway. So once you have unified your network in one cloud, the work is not done. I'm sure a lot of you will reflect on this, that multi-cloud strategy is real, and it's probably going to stay. And your reasons could be different. It could be DR strategy, or it could be compliance. Or it could just be that certain workloads run better in different cloud providers. Maybe or you have some Oracle databases and you want to move it to Oracle Cloud, and your applications are in Amazon, things like that. If you think about it, we had the same challenges. Now you have workloads in different clouds, and they need to talk to each other, and traversing internet is not an option. You need to have a way to interconnect these cloud providers through some sort of a cloud exchange fabric where you get high bandwidth and low latency, which is probably going to be in sub-milliseconds. And not only that, you can connect it with all your internal networks in your organization. So in this case, we have fully wired with all our cloud providers, all our data centers, all our branch offices, and traffic never leaves internal network. Cloud adjacency, this is an extension of multi-cloud exchange fabric. Essentially, what you're doing is you're identifying how to implement it, the interconnectivity between different clouds. Your clouds are literally together somewhere in a co-location facility. One of the benefits of doing this for us was to avoid vendor lock-in. We know that once you are in any cloud, it's extremely difficult, almost impossible to get out of it. But once you have these things in place, and if you write your software in a more abstract fashion, you can migrate your workload from one cloud to another cloud, as long as you have interconnectivity in place. A lot of people don't think about these things until it is very late. And of course, you can use the best features of each cloud. We use Systems Manager from Amazon for our patching, but that should not limit us to just patching our systems in Amazon. We should be able to use the same service to patch servers in Oracle or Azure or even your data centers. And that brings me to the DNS internalization part. If you see, there is a theme here. We are trying to bring services internal to the company. Of course, you have some UI component and user-facing component which needs to be running on public. But as we expand into cloud and people start to use these microservices, it's just so easy to build these services publicly. Because you have opened your cloud to hundreds of developers and engineers, you are not monitoring them. You're not necessarily ensuring that if the service is supposed to be internal, it remains internal. We had the same challenges. How do we bring these services internal? Now we have solved the routing challenges using transit gateway. We know the connectivity is there, but can you resolve your names from one network to something which is another network? Public, of course, you can resolve, but what if it is internal? You need a strategy to bring things internal. You need to identify your internal domains and have some sort of mechanism so that you can resolve these names from your data center, from your multiple cloud vendors. It should just work seamlessly. It should not feel like, of course, if you work in Amazon or any other cloud, if you are in the VPC or in one network, you can resolve any names, no problem. But if you go from one network to another, problem galores. It just does not work. And then people go into deploying those services as public endpoints. And that's not a good security practice. By just doing this project itself, and by the way, this is still in progress, because one of the challenges we have is to working with the teams and migrate their services internal. It's a little bit of work, even though we have the infrastructure in place. By bringing these services internal, we were able to reduce 30% of our publicly exposed API footprint. And our security team was just delighted with that. Our security scorecard is probably the highest in the industry. And here is the architecture diagram. And we have solved this problem in Amazon. We are still working on the other cloud vendors. But the same concept, the hub and spoke model. You have a centralized DNS account. We use Route 53 resolver. And you have a bunch of child accounts. In our case, we have more than 150 networks. All these child accounts are sending requests to the centralized account for any kind of name resolution. And you have forwarding rules in the DNS, in the main DNS account, which can send the request to either to your data centers, if it is a data center specific query, or it can send to the other clouds as well. So now you have brought your services internal, which needs to be internal. You have solved the problem of routing. You have fast, high-speed interconnect, which stays in the cloud. And also, your security posture is improved. your attack surface has been reduced considerably. Quickly touch base upon some of the guardrails. And we spoke about how guardrails are the ways to be able to operate in the cloud at the scale we do. Give a few examples. You don't want to allow your S3 buckets publicly, whether it's read or write. But I'm sure if you go and look, you'll find a lot of buckets which are still public. How do you ensure that your engineers and developers who are creating hundreds of buckets a day, they are actually following your best practices? You can have those best practices written down somewhere in your wiki, but if people are not following, it's extremely difficult. And then next thing you know that these buckets have secrets and passwords and API keys and things like that, right? Have a guardrail. If there is a bucket created publicly, an alert should go out immediately, or in some cases, you can even block that action, unless there is an exception process, which might be a case. Disallow unapproved regions. If you are operating in US, all your customers are in US, you don't need to build your services in Europe or Asia. But people, maybe you have a geographically diverse people and working from different locations, and they might not know, and for them it might be easier to spin up the services in different regions. But you don't want to get into that situation much later because, trust me, it's very hard to fix it after the fact. Disallowing port 22 from internet, I think that's a big one for us. A few years ago, our security team will literally have every single week, they will have emails sent out to various teams that, hey, why are you allowing port 22 from internet? And teams will be like, oh, I don't know. It just, by default, it's like that. Such a huge risk. Do not allow it. Don't allow any unapproved images. If you know you have, like in our case, we have about 10 machine images, which is approved. We call it base AMIs, and then we use them to create derivative AMIs. As long as any instance is launched using one of those AMIs, good. If not, an alert and notification is sent out. And in certain cases, we even take action and terminate those instances before it. So when you do this, it doesn't make its way into production because you have killed it in dev or POC environment itself. So as you can see, that scaling and be able to operate in cloud in such a fashion where it is cost effective and reliable as well as security is high, it takes a lot of thinking, and guardrails helps us with that. Cost management, same. I think scaling can be applied in cost management as well. A lot of people think that cloud is getting expensive, but that's not the case. Cloud is still the same. In fact, the prices have been going down. It's the waste in cloud a lot of us don't realize. Waste like shutting down your instances or terminating them, but leaving their volumes behind. We have been able to save hundreds of thousands of dollars by just automating our EBS volume cleanup, just one thing. Now think about other things, like load balancer, but has no backend instances. Or you have snapshots sitting for like 5 years, 7 years. We started cloud journey way back in 2013. So there's been a lot of craft has been developing. More than 100,000 snapshots were found, and that's when we realized that, okay, we have to get ahead of this problem. And now it's fully automated. And of course, the best practices and cost improvements needs to be rolled into your automation. I'll give a quick example. Amazon keeps coming up with new features. One of the new features was EBS volume GP3 type. Now, if all you are using GP2, and you could have literally hundreds of thousands of such volumes, how are you going to ensure that you can migrate from GP2 to GP3 and save 20% of your cost at the same time improving performance? Are you going to work with all the teams and ensure that they will do it? Probably not happen. If they're using the shared Terraform modules and everybody is launching their instances using the same shared Terraform modules, you can just fix it in the code. And whenever they launch the new services next time, or whenever is the next release, it will get fixed automatically. And of course, cost anomaly alerting. I think most of the cloud vendors today provide this feature and services, where if the cost starts to drift in your accounts, you get an alert. That has helped us tremendously as well. With that, I'm going to be talking a quick demo on monitoring as code. It's a software developed by McGraw Hill. we used it heavily. It has changed the game for us in the monitoring space. So it is pre-recorded. I'll just play it. But let me talk about this. I'm sorry, the demo is not working. But essentially, let me give you the rundown of what this means. Back in the day, whenever we released new services and new infrastructure, somebody would have to go and create monitors. You're talking about hundreds of services. And when you release these services again, somebody has to go and change the monitors, whether it's APM or browser or synthetics or infrastructure. This was getting burdensome. It needed to be automated. This software essentially allows us to recreate your monitors in minutes, literally. And also helped us tremendously when we moved from one observability platform to another. It took us weeks as opposed to months if we needed to do it by hand. So I'm sorry I couldn't show the demo. Maybe I'll send a link later in the Slack channel. It is pre-recorded, and we'll share with you guys. OK. And we have a few things on the horizon as well. We are still, as I said, in SRE world, there is a saying that you fix a problem and then you move on from one problem space to another. A few things we are still working on is network segmentation, so that you can separate your traffic, production traffic, from non-production traffic, zero trust architecture, deprecation of SSH fully. Nobody needs to log in to the servers anymore. Intent-based networking, AI ops, and advanced automation. With that, thank you so much. Thanks for sharing your time with me today.